In the last video in this tutorial series, we had imported some LAS data. We'd done a little bit of editing of the well logs, and then we want to try to create a synthetic. And when we did, we went to synthetic. We just wanted to do a 1D model, and it told us that we didn't have any P wave. Before we add the P wave curve and we show how to add what we call custom curves, I want to refer you to this button up here on synthetics where it says set modeling curves. Okay, so these are the modeling curves that would reside over the tree, and this tree could grow significantly as we add more curves. But in order to create synthetics, I need a certain set of log parameter curves. I need a bulk density, which is shown here black, and I've got one. And I only have one bulk density curve, and it's been picked. I need a P wave, and it's shown in red, and I don't have a P wave. Those are required, P wave and bulk density, to do any synthetics. If I want to do an AVO, I'm going to need a shear wave. And if I want to do some fluid substitution, I'm going to need a shale volume curve. But right now I don't have a P wave curve. So how do I add that P wave curve? I come over to the custom curves node in the tree. This is where we're going to start adding derivations of curves based on our well log data. And if I click on that node, I can always go to curves at the very top, curves, add custom curve, or I can right mouse on this node and hit add custom curve. Now I need to tell it what type of custom curve I want to add. There are all types of log parameters that TIPS knows all about, everything from acoustic impedance to conductivity, gamma, gas oil ratio, resistivity, so on and so forth. But we know we need a P wave curve. So the parameter that we want is a P wave. I'm going to hit OK. Now we have to tell TIPS how do you want us to calculate the P wave curves. There are various methods based on the data that you would have available to you in your well log. The first option that we have to pick from up here when it says calculate is the method used to calculate a P wave curve. And we can calculate it based on the sonic, or we can calculate it if we had a VPVS. Now down below, based on this method, it tells you what curves are required, what parameters are required. So if we're doing a sonic, all I need is a sonic, and I only have one sonic curve. Just to show you, if we pick VP over VS, it would say I need a shear wave curve and I need a VP over VS curve. And I don't have either one of those. We'll go back to sonic, and it's telling me that the only curve you have available is this sonic DT that is over here. And when I hit OK, it then computes the P wave curve based off that sonic, and it doesn't show it automatically. I can click on it and say show curve, and it's going to show my P wave derived from the sonic. That's why the P wave open print sonic, so we know how it came from. And it's shown up here from 5,000 to 20,000 feet per second. And if I like to have the P wave all far to the left, and I can click on these little chevron arrows over here and keep moving it over, or I can always go to view chart layout and take my P wave and move it to the top. So now I have P wave, bulk density, and the like coming across. So that's how we add a custom curve, and we can do that on and on. But it always prompts you when you go to add a custom curve to let you know what log parameters are needed to produce it. Now what I'm going to show now is one it's kind of interesting. It's very useful to have, especially when you're doing fluid substitution and the like, and that is a shale volume curve. So I'm going to come over here to custom curves, and I'm going to say add a custom curve. And I'm going to come down to scroll down, and I've got one for shale volume. And I hit OK. And it says, how do you want to generate that? What method? Again, these are the methods. If you had a sand volume, it could create that. It would be 1 minus that. But you can also see down here, you don't have a sand volume curve. I could also generate off of the gamma or the SP. And I'll look at the curves over here. So that's my SP curve, and that's my gamma curve. And those can be used to estimate the shale volume. I'll just use the gamma for now. Now I'm going to hit OK. And now I've got a new menu that pops up. This is a unique menu for defining sand shale volume curves. So on the left, this is our guide curve. This is our gamma curve. This is the data pulled from here, from our well log. And on the right, it's going to be the shale volume as we begin to estimate it. Now, by default, we have everything here as lithology is either sandstone or shale. We can change those later, and it will not impact this whatsoever. So the way we go about defining a shale volume is we're going to use the gamma curve to set the sand 100% sand bounds and the 100% shale bounds, and then it will compute it on the fly. How do we do that? Well, we go at the top. First of all, we have these view controls, just like the rest of tips, and I can drag and zoom in here and scroll with my mouse wheel if I like, and I can look at all those values as I'm scrolling up and down. So I'm going to zoom in just a little bit to go to the top. So first thing is we're going to pick our 100% sand points, and we go to the top, and we have this little brown square with the asterisk on it. It says add sand points. When I click on it, that half of the gamma curve turns that shade of brown to let us know, all right, we're going to be picking points on the edge of this curve. And these are our 100% sand points. And I can just start picking data points. And you'll see what I'm going to do is pick along the edge of these curves. I'm not going to be too exact right now because I don't have to be. But you can see how I'm picking and describing those points. And I'll come back to show you how we can edit. I'm going to zoom out now so we get a bigger picture. I'm still adding points. That's my mouse mode up there telling me what it's going to do. And I'm just picking here. Now the selection of points when you define this is really a bit of an art that geophysicists used, and I've seen some pick a very coarse level and some very granular level. It's really up to the interpreter, the well-log modeler, as you're creating these. And you can see what I'm doing is I'm picking points on the far left to define the bounds of these curves. And I'm zooming out just a little bit here in a second, and I get down to the end, and now I'm done. So I've picked those points, and you see that I've picked them on the left side of this curve. I'm going to zoom in a little bit more, and you can see I've kind of picked the peaks along here. If you don't like any of those, you can pick on a point and move it. Okay, if you want to add another point right in the middle, I want to add one right here. You go back up to add points, and I click right here, and it will add those points. If I want to get rid of a point, I can click on that, and on the delete point button, and delete. If I want to delete the whole curve and start over, I would hit that one. So I'm going to add another point there. Okay, so now what we've done, and I'll zoom back out to everything, is this set of data points defines where we feel we have 100% sand content. Now guess what? We're going to do the same type of thing on the other side of the curve. That will define our 100% shale bounds. And I come over here and I click the button to start adding shale points. And you'll notice it turns green, which is what we're using to discriminate between the display within the sand and the shale. And I'm going to add points on the right side. Now you notice the minute I add these, my shale volume curve is displayed. Now I'm going to zoom in as we do this, just so that you can see. We're still adding shale points. This is our mode up here. But it's every time I click it and add a point, it's recomputed. And you can see that it's using the bounds of this curve, that this is 100% sand, 100% shale. Over here, if it's gray, that's our shale, and we've got a key down at the bottom. Our yellow is sand. So the areas that are mostly yellow are high sand content. Areas that are mostly gray are high shale content. So I'm just going to come and roughly pick some points. And again, it's the artistic technique, if you will, of the user to determine where you want to put these points. And I'll do a rough bound up here and wrap it up as we get deeper. Let me zoom out so we can expedite this process. Okay, so now I'm done, and I've created my estimation of sand and shale content based on the gamma curve. When I hit accept, I now have my shale volume curve, and it says open paren gamma. That way I know where it came from. And if I want to display it, I go right mouse on it and hit show curve. Now the shale volume will always have this special display where it's filled in based on the lithologies that we're defined in this area. In this particular case, everything is either sandstone or shale. In a separate video, we'll talk about how we specify the different rock types that are out there. So now I have added a couple custom curves, and we'll be able to start taking our modeling to the next level pretty soon. But that's a real quick and easy way to add and define a P-wave curve and a shale volume curve. Now we're going to save this at this point. One thing that's also worth remembering, when we save this in our project file, we're not saving we're updating the LAS file. I've not written out a shale volume curve. I'm saving the commands used to produce that. And that's key as we look to restore models later. In the next video, we'll get around to creating some synthetics.